So here's an example of utilizing the Young modulus. A spring made from material with K is 56 newtons per meter is pulled by a force of 11.2 newtons vertically downwards. The base of the spring is a circle of radius 5 centimeters. Assuming that the force is spread across the circular base, find at x equals 0.12 meters the stress of the spring and the Young modulus of the spring, given the initial length is 35. So go ahead and try this problem, and when you're ready, come back for the solution. So, whoops, don't know why that's happened there. So the first thing we have to consider is to write down all of our variables. We know that K is the 56 newtons per meter, force is 11.2, and the radius is 5 centimeters. So force is 11.2, and radius is 0.05. Now, with the Young modulus, you have to remember that sigma is force over area, and epsilon is change in length over natural length. So we're going to assume that the base is perfectly circular. So we have the area of a circle is pi r squared, which is pi by 0.05 squared. Which I'll write as pi over 400 meters squared. Now we can find sigma. So sigma is 11.2 divided by this pi over 400. Which gives us 1,426 newtons per meter. So we're done for the stress, so that is the stress. So that is part 1 done. Part 2 tells us to find the Young modulus given L0 is 35 centimeters, so 0.35. Now it's stretched at x equals 0.12, and so epsilon is going to be the change in length over the natural length, which gives us a 1.34. Remember, the unit is dimensionless. So now, capital E is sigma over epsilon, which is 1426 divided by 1.34. Which gives us 1,064 newtons per meter. So it's key to note that because epsilon is dimensionless, the Young modulus and the stress of the spring have the same units.